Hello guys, Teacher JC here. I hope that you are doing well wherever you are right now and that you still be able to do the lessons given. For this week, for your robotics class, we are going to combine all the lessons from week 1 to week 3. Now, unfortunately, not everyone can interact with a robot, or more specifically with an Arduino. That's why I'll be showing you a demonstration just so you can have an idea on what it looks like for this Arduino robotics. Okay, so if you have a PC or a laptop, okay, you can go to tinkercad.com, and so that's tinkercad.com, and log in if you want. Again, if this is only if possible, but it's not mandatory. Okay, so Tinkercad is a virtual simulator of applications such as AutoCAD and Arduino. Okay, so it will show you a virtual representation where you can interact with these components. Okay, let me remove that one for meantime. Now, first week the first week you learned about what robots are, and according to the description, robots are also called your droids. Okay, so droids are machine which are programmable by a computer. So with this, you can already know what's the difference between an ordinary machine and a robot. Okay, so next one is robots are autonomous, meaning they can work on their own, such as factory robotic arms, okay, for welding, for putting stuff together. Okay, and another one of its description is it's semi-autonomous, meaning some parts it can do on its own, but it still needs human intervention, okay, human input. Now the second week is about your MCU, which is your microcontroller unit, and its different parts. Now in Tinkercad, we have here Arduino Uno R3. Okay, so that's the same. Now in here it's also presented on your notes that it has different parts. So first, your LED lights, we have 4 of those. We have for your receiving, we have for your transmitting or sending, so it will light up when it's sending data. This one is for troubleshooting if it has problems, and this one will basically turn on if your Arduino Uno is plugged in, or your MCU is plugged in. Next one, we have 2 power sources. One is your USB, and the second one is your barrel jack. Next, we have your reset button. Now when you press this one, it doesn't mean it will delete everything that you save inside. Okay, it will only restart. Okay, just like when you restart a computer, all the programs that you installed will still be there. Okay, it's just that you turn off the power and you turn it back on. Now there are 2 sides of pins, one for your digital pin mostly, and on the other side is mostly your analog pin side. So we have digital pin and analog pin. Digital pin basically interacts with inputs called binary. Okay, so binary meaning 2. Bi means 2. So it can interact with inputs which are zeros and ones, true or false, on or off. On this side also you can see ground. We have RX for receiving, TX, so the same as this one. Same label as this one, but this is where you connect it to transmit. This is where you connect to receive data from other sources. So we basically use, or we mostly use, the digital pins from 2 to 13. Now, on the analog side, we have 6 analog pins. Analog meaning it can deal with values ranging from 0 to 1023. Okay. Now on the analog side, we will only be using this analog pins, 2 grounds. We have and your 5 volts usually. Okay. Next. Now if you're wondering what the rest are for, you can search on those. But for now, that's what you need for as an introduction. Next one, we have your breadboard. So I'll be using a small version, and breadboard small. Okay, and then we have 3 parts to this. We have your horizontal pins. So if you notice, if I hover on one of the horizontal pins, the rest of the line, the row, will be highlighted, meaning they are interconnected with each other. Okay. The next one we have is your vertical pins. So again, if I hover, you will see the other pins that are interconnected with the pin that I hover onto. Okay, so that's per column. Now, if you're wondering, sir, why is it not connected to the one below? Okay, so that is because of the trench in the middle. Okay, so if you go over back to your notes, you will see there that there is a trench that divides the vertical pins. Okay, so if I connect a wire here, okay, to digital pin 2, okay, it doesn't mean that it's also connected to this one, ground. Okay, it's not connected. But if I move this one to here, it will now be connected to this wire. Okay, now moving on, we have now your what do you call this, resistor. So let me just find a resistor. So this is an example of a resistor. Now usually the resistance value that we use here is 220. Okay, so that you can see your LED lights bright enough, or it will turn on bright enough. Now resistor, if you actually read the lesson, watch some videos, so it just limits the flow of power that passes through it. Okay, so so this one actually protects your LED light. Now LED light sample is this one. Let's change it to green. So LED light has 2 pins. Now I will go back to resistor later. LED light has 2 pins, one short, the cathode, and one long, which is the anode. Okay, according to your lessons, the way you connect this one is you connect your short pin. Again, don't get confused, your short pin to the ground, and the long pin to your 5 volts. Now if you do that one directly, let's try doing that. So let me just remove the breadboard for now. If we do that one, so ground to cathode, let's change it to yellow, and 5 volts to anode. Okay, so if we power that on, okay, you notice there that there is a what do you call this, picture shown that it would pop, well, a little bit of explosion, or it will actually break your LED light. Okay, so what happens there is the LED light have been the power is too much for your LED light to handle. Now this is where your resistor comes in. Okay, so what do? We connect your resistor to be part of your circuit. Again, circuit should be a continuous flow of energy from the source going back to the source, to its negative charge. Okay, so from 5 volts, so consider this one as your power source, like a battery. Okay, so it from 5 volts it will go to your LED light, passes through your LED light, and then there should be a wire that should leads to your ground. Now let's try connecting your resistor. Let's change this one to yellow. Sorry, might not be able to see the purple. There you go. And when we start the simulation, you will see now that the explosion logo is no longer there, but there's a little bit of there you go. So it should be fine. Okay, so that's how you turn on your LED light. Okay, so always place your resistor. Now, sir, what if we mistakenly place it on the other side, this side? Okay, so let's try that out. Let's remove this. Let's move this one to your anode. Now let's create a line. Goes to your 5 volts. Change it to turquoise. Yeah, there you go. Now when we start simulation, okay, it's not working. Okay, now can you identify why? Okay, the problem is that again the long pin should pass through your should be connected to your 5 volts. Okay, so this is actually wrong. Okay, so the way we fix this one and transfer your resistor is this way. Okay, now your call this anode now is connected to your 5 volts. Your cathode is connected still to your ground. The difference is we changed the placement of your resistor. So when we start, okay, it's still the same, it's still working fine. Okay, so it doesn't matter where you place your resistor, for as long as there is a resistor within your circuit that will control, okay, that will limit the power that would pass through your Modules are your LED light and other components. Now, sir, where do we use the breadboard? Because on my example, we did not use a breadboard. Okay, so from the notes that I've given you before, breadboard acts like an extension. Okay, and at the same time, it is used for prototyping. Now, prototyping means you create a design, okay, a robot which is not yet finalized, meaning you can easily change the connections if there needs some changes. Okay, so for example, let's recreate this LED connection and connect it to your breadboard. Now, if you want to connect your cathode to your ground, there are now 4 pins you can use. For example, I want to connect wire here, then connect it to ground. Okay, so let's use red. Now, what if we are going to connect a resistor on this area? Okay, so we connect it like this. So the pin of the resistor should be inside this pin here, terminal here. Okay, and the other side of the pin should be on this side. Okay, so it affects the rest of this. Now, how do we connect this part now of your resistor to your 5 volts? So it's up to you to choose which among this one, and either way they are all the same. So when you click that one, okay, and you want to connect it to your 5 volts, then you may do so. Okay, now it's connected. So you don't have to directly connect it like this. You can connect it using the other pins. Now when we turn it on, it should still work just fine, the same as when it doesn't have a breadboard. Okay, so that's for your breadboard and your MCU, LED light, and resistor. Now, let's try now adding a LED light, adding more LED lights. Okay, so LED lights. So let's try using 3 LED lights. Green. Oh, sorry. Let's go red, orange, and green. Okay, so you align 3 LED lights. There you go. Now, what will happen if we want to turn on all 3 LED lights, okay, but we only have 5 volts? Again, breadboard acts like an extension. So let's also use 1 ground pin for all 3 of these. Okay, so how do we do that? So first off, let's add resistors for all 3 of them. I'll put a resistor here, put a resistor here, and another one here. Okay, so if you're wondering, sir, Isn't that the same line? Won't that make any problem? No, it won't, again because of this trench line. Okay, so the groups here is different from this group. Now what I did now is to connect this one to your cathode for the red LED light, and we can connect the other side using all the rest of these pins. Same for the rest. Okay, now I'll be using 5 volts for what do you call this one, horizontal pins at the bottom. Okay, and connect it to this one, while ground will be connected to this line. Let's change the color to brown and gray. Is gray okay? No, let's do pink. Okay, now meaning ground now, or this line, this horizontal pin, all of it will now become ground. If you look at this one, if you notice, because it's now connected to a single pin, now it has been extended just like an extension wire and made all the rest of these pins into a ground pin. Okay, so what can we do now? We can connect one pin here, a wire here, and connect it to your resistor, same as this one and same as this one. Now, just like this ground, wherein the rest of these horizontal pins becomes ground, 5 volts now will also, this wire to 5 volts will now create or make the rest of these horizontal pins into 5 volts. Now remember, this line is separated from this line. So what we can do now is to connect one wire here to turn this one on, so it has a circuit of its own now. So it will pass through here, passes through this wire, goes to your resistor, and then passes through your LED light, then goes back here to your 5 volts, connects here, and then the circle is complete, or the flow is complete. Now we can do that one, repeat that one for the second one and for the third one. So let's just change it to green, change this to orange, and change this to red. This one is for resistor. I'll just turn it black and black. So when we start simulation, all of them will turn on. Okay, so that's how it is. Now for your activity, check on the post and try to answer it. Now, bye and good luck. Stay safe.